Howdy. This video will focus on what solving systems of linear equations by substitution is, how to solve by substitution, and a few examples of this. So, what is substitution? Solving by substitution is simply a method of solving a system of equations where we solve for a variable of one equation, plug that variable into the second equation, and then solve for the second variable. Then we plug the second variable back into the first equation. This sounds like a lot of work, but trust me, it's not that bad. I swear. Alright, so moving on. The steps to solve by substitution. So step 1, solve for a variable on one of the equations. Step 2, plug the new equation into the second equation. Step 3, solve for the variable. Step 4, plug this new solved variable into the first equation. And then we solve for that variable, and then we have the solution acquired. One more slide before we get into some examples. Why can we not solve for a variable and then plug that variable back into the original equation? So let's say we have y equals 2x plus 3, and let's say we have 2x plus 4y equals 6. So let's go ahead and solve for this x here. Let's solve for this x here. So we're going to move this 4y over. And then so now we have 2x equals 6 minus 4y. Now I want to get x by itself, so let's divide by 2. And x equals 3 minus 2y. Now let's accidentally plug this x back into our original equation. We're going to get 3 minus 2y plus 4y equals 6. So then we'll have 2 times 3, so 6. 2 times negative 2 is minus 4y plus 4y equals 6. So then the negative 4y and the positive 4y will cancel, and we're given 6 equals 6. That's what happens when we solve for the variable and plug it back into the same equation. We get a statement of 6 equals 6. And this isn't what we're looking for. We're looking for an x equals something and a y equals something. Okay? So do not plug the variable you solve for back into the original equation. So solving by substitution. Given 2x minus 3y equals negative 2 and 4x plus y equals 24, solve this system of linear equations by substitution. So we have 2x minus 3y equals negative 2, and 4x plus y equals 24. Let's solve for a variable. The easiest way to do this is, let's solve for this y here. So how do we get y by itself? We're going to subtract 4x from both sides. So minus 4x minus 4x. Then we're left with y equals negative 4x plus 24. Now let's substitute this y into this second equation. So we have 2x minus 3. Because this y equals negative 4x plus 24, we're going to replace this y here with negative 4x plus 24. So parentheses, negative 4x plus 24 equals negative 2. Then we're going to distribute our 3. So we have 2x plus, because a negative times a negative is a positive, 12x. Negative 3 times positive 24. We're going to have 3 times 4. That's going to be 72. So minus 72 equals negative 2. Now we want to combine our like terms on each side. So these are like terms. So 12 plus 2 is 14x minus 72 equals negative 2. Next, I want to get x by itself. So plus 72 to both sides. This cancels. So we're left with 14x equals 70. Because 72 minus 2 equals 70. Next, let's get x by itself. So divide both sides by 14. So then x equals 5. Okay, now we solved for x. Let's plug this x back into one of the equations. It doesn't matter which one. So let's just plug it into this equation since we know what x is. So let's bring this equation over. So we're going to have 2x minus 3y equals negative 2. So plug this 5 in for the x. We're going to have 2 times 5 minus 3y equals negative 2. 2 times 5 is 10. So 10 minus 3y equals negative 2. Now we want to get this negative 10 over here so that we can have this 3y by itself. So let's subtract 10 from both sides. So this cancels. We're left with negative 3y equals negative 10 minus 2. That's negative 12. Now we want to divide by negative 3 so we can get y by itself. So divide by negative 3. That cancels, so we're left with y equals negative 12 divided by negative 3 is positive 4. Okay, we're not done yet. We're almost there. One more step. We need to put this x and this y in coordinate pair. So in coordinate pair, our answer will be 5, 4. Because we just moved this 5 into the x coordinate spot and this 4 into the y coordinate spot. Okay, I know that's really messy. I'll get better at this. Alright, moving on. Solving by substitution. Another example. Okay, so we're given y equals 36 minus 9x and 3x plus y over 3 equals 12. Solve this system of linear equations by substitution. So we have y equals 36 minus 9x and 3x plus y over 3 equals 12. Guess what, guys? Our first step is already ready for us. We already have y solved for on this equation. So let's just plug this y into this second equation. So we're going to have 3x plus parentheses 36 minus 9x divided by 3 equals 12. So then let's bring everything down. So 3x plus 36 divided by 3, that is 12. And then minus 9 divided by 3, that's 3x equals 12. Okay. So now let us combine our like terms. So we're going to have 3x minus 3x, and we're left with 12 equals 12. Alright, let's think. What does this mean? This means that our slopes are parallel. Let's go ahead and do something. Let's solve for y on this equation. Right here. So let's to see if our slopes are the same and our y-intercepts are the same. To see if this is either inconsistent or dependent. So let's subtract 3x from both sides. That's going to be y over 3 equals 12 minus 3x. Now you want to get y by itself. We have y divided by 3. So in order to get rid of that 3, we need to multiply both sides by 3. So that cancels out. So we're left with y equals 36 minus 9x. Looky there. These two equations are the same thing. So this system is dependent, and we have infinite solutions. This would be our answer. Alright, this is officially our last slide. Sorry for the confusion. Given 7x plus 2y equals 16, and negative 21x minus 6y equals 24. We want to solve the equations by substitution. If I may point something out, I already noticed that 7 is a multiple, 21 is a multiple of 7 by 3, and 6 is a multiple of 2 by 3. Something looks fishy. So, you know what? For the heck of it, let's solve these for y. Both of them. So, we have 7x plus 2y equals 16. Let's subtract 7x from both sides. That cancels. We have 2y equals 16 minus 7x. Let's divide both sides by 2 to get rid of that y, to get rid of that 2. So we're left with y equals 8 minus 7 over 2x. Okay, let's solve for our other equation. We have negative 21x minus 6y equals 24. Let's get y by itself. So we need to subtract, add both sides by 21. So add 21x to both sides. So we're left with negative 6y equals 24 plus 21x. Now to get y by itself, let's divide by negative 6. These negative 6 cancels, so we're left with y equals 24 divided by negative 6, that's negative 4. 21 divided by 6, that's 21 divided by negative 6, that's going to be a negative 7 over 2x. Looky there. We have the same slope. And by definition, when we have the same slope, the lines are parallel. So parallel lines, that will be inconsistent, independent, or dependent. It's going to be inconsistent. So inconsistent. And when we have an inconsistent linear system, we have no solution. And that is our answer. And that is all, folks. So thank you for listening. Remember to take your notes. I'll be checking those on Monday. And have a great day. Thanks, guys.